Okay, let's continue our discussion. We had learned about valence electrons and how to determine the number of valence electrons using the periodic table. Those are the things that we have learned so far, and that you've learned that valence electrons are needed, okay, in showing the formation of compounds of substances, okay, through the different um, types of chemical bonds. Now, this works during chemical reactions. Chemical reactions, elements combine, okay? They rearranged or break apart with others to form new substances. The new substances are created when chemical bonds are broken or created. So as seen here on the example, we have a magnesium metal, and magnesium metal will undergo a chemical reaction by adding energy, okay? Thus, it will create magnesium oxide. Or shall I say, if we have magnesium, one moment, reacts with oxygen, it will yield magnesium oxide, okay? Which means to say, class, that this is a new substance. New substance is formed. Magnesium oxide is different from magnesium and from oxygen. Now, what happens here in magnesium and oxygen? The elements are still the same, okay? The elements are still the same. Just try to picture out that those valence electrons that you have learned, they are in charge in forming this magnesium oxide. In analogy, they will rearrange either rearrange, either it will combine, it will grab electrons, the valence electrons, okay, or shall I say, it will work with another electrons, okay, mutually to come up with a substance. So that's what's happening in a chemical reaction. Now, uh, during chemical reaction, there is always what we call as the original substance, okay, and then new substances form. And with this, new substances form can be uh, an element that is coming from the original substance, or it can be a compound. Okay, so compounds are one or more than one kind of element joined together. And why elements form compounds? To satisfy the octet rule. The elements joined with another element to satisfy the octet rule. And this describes how chemical bonds happen. That's octet rule. Why? Because atoms want a full valence. When we say full valence, okay, the atoms or outer electron energy level should have 8 valence electrons. Okay? So remember, we have sodium, which is 11, and fluorine, which is 17. Okay? So we have 1s2, 2s2, 2p6, 3s1. As the electron, the configuration shows, okay? I demonstrated this in our synchronous class. We have 1s2, 2s2, 2p6, 3s2, 3p5. When we say full valence, the outermost energy level should have 8 valence electrons. So in the first energy level for sodium, it has only 2 electrons. In the second energy level, take note, this is the second energy level, okay? This 2 means second energy level. It's 8, right? And then on the last or outermost energy level, we have only 1 valence electron. Then on the other hand, we have for chlorine, We have 2 on the first energy level. We have 8 and we have 7. Okay. So atoms to achieve want to achieve full valence. Is this full valence? No. What about this? No, it's not. Okay? So it should be 8 electrons. It should be 8 electrons. Now with this, what is the, if this is, if you will be asked, how are you going to make it full valence? Then they have to combine with another element. When combining, we means grabbing the electrons of one element or giving it. So if you notice here, what will sodium do to achieve full valence? Sodium needs to give up. If it will give up, what is left? 8. Therefore, it will achieve full valence, right? Here comes chlorine. Chlorine needs one more electron to become full valence. Thus, okay, sodium will give it to chlorine. Imo na lang na siya, chlorine, kay sobra man na siya, right? Therefore, this will make chlorine full valence. If the atom gives up an electron, it becomes an ion. And this becomes Na positive 1. This is a cation. It means it gives up electron. Chlorine atom receives an electron, and then it becomes an ion when it receives an electron. And what happens to chlorine? Negative, okay? This means that what? Okay, this means that chlorine receives an electron. Why negative? It means that electrons, there are more electrons than that, okay? Therefore, this becomes an ion, and particularly we call it anion. Okay? So if it gives up, it turns into a cation. If the atom receives electron, grabs electron, it turns into an ion. Okay? I hope it's clear. Now, okay. Now moving on. So we've learned about the valence electrons, first energy. I mean, this is group 1, group 2, 1 valence electron, 2 valence electron, 3 valence electron, 4, 5, 6, 7, 8 valence electrons in its corresponding group. Okay? So please be reminded of that. Another, it is easier. Now, to reach full valence, some atoms want to lose electrons and the others want to gain electrons. Okay? So for atoms with fewer than 4 valence electrons will bond by losing those electrons. Okay? It is easier. So let's have groups 1. All group 1, okay, group 1 has positive 1 valence, has 1 valence electron. Okay? Group 1 has 1 valence electron. Now, what will it do? Group 2 has 2 valence electron. Group 3 has 3. Atoms present or found in groups 1, 2, and 3, it is easier for those atoms to what? To lose electrons rather than gaining. How? Why? Why are they going to lose electrons? So that they will achieve full valence, right? Okay. So, atoms with more than 4 valence electrons will bond by gaining electrons in order to achieve the full valence. So remember, group 5 has 5 valence electrons. which means to say, the valence electrons, which means to say that, okay, in order this to achieve full valence, it needs, okay, to gain 3 electrons. Group 6 has 6 valence electrons. To make it 8, it needs to gain 2 electrons. And group 7 has 7 valence electrons. It needs to gain 1 valence electron or 1 electron. Okay? 1 electron. No? So, with that, it is easier for uh, these atoms present here to gain 1, 2, or 3 electrons rather than losing 5 electrons, 6 electrons, and 7 electrons. Okay? Next, atoms with 4 valence electron can gain or lose electrons. What about 4? Carbon is 4. It depends on the element to which it is bonding. Okay? Now, we will be representing these electrons. We will be representing these electrons. Okay, take note using the LEDs. Okay, LEDs stands for Lewis electron dot structure. Okay, so Lewis electron dot structure. The valence electrons determine on elements chemistry. Lewis dot symbol represents the valence electrons of an atom as dots arranged around the atomic symbol. Okay, Lewis electron dot structure is most useful for main group elements, which means to say, Lewis electron dot structure is made up of what? It is made up of a chemical symbol and dots. So, chemical symbol. This chemical symbol represents the This represents the atom. And what else it is made up of? Dots. These dots represent the valence electrons. Okay. Now, so it's most useful in representative elements. So take a look at the Lewis dot structure, electron dot structure of all group 1. What do you see? Chemical symbols, and then it has 1 dot because group 1 has 1 valence electron. Chemical symbols for group 2 with 2 dots because it has 2 valence electrons. 4, 3, group 3. So if the element is found in group 3 like aluminum, it has 3 dots to represent the valence electrons. And we have silicon, 4 dots, phosphorus, nitrogen, 5 dots. We have oxygen, sulfur, and the rest have 6 dots. We have 7 dots and 8 dots. So when atom forms compounds, it is their valence electrons that actually interact. So the Lewis dot symbol, the Lewis electron dot structure symbol consists of the element symbol surrounded by dots. Each dot represents a valence electron. So if we have boron, boron has 5 electrons. So we distribute it using the electron configuration. So we have 1s2, 2s2, and 2p1. So we have here 3 valence electrons. The Lewis dot symbol is, this is the 3 valence electron. The Lewis dot symbol can be written like what? Please use the clock system to organize the dots so that it can be seen clearly by your teacher. So when we say clock system, let's just say the element has 7 valence electrons. Example. So how will you distribute the dots? How will you distribute the dots? So use clock system. You may use 1, 1, that's 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. What happens? Then pair it. It means it's a paired electron. Next, this one, and then this one. And then there's 7 electrons. Can you write other ways? Just like this. It's written in other ways. So we have another way to write it is we can write this way. So how many paired electrons? How many paired? 3 paired, okay, electrons and 1 unpaired electron. So paired because that's it. That's the 3 paired electrons and we have 1 unpaired. Okay. Now another. Let's have another. Okay. What about if we have magnesium? How will you represent magnesium? Magnesium has 2 valence electrons. You can have 1, 2, okay? Or we have magnesium can be written like 1, 2. It's possible as long as the dots are in the clock system. Why do we do this in the clock system? To organize the dots. Okay? So you can rearrange the dots. Now, therefore, my dear 9G students, okay, so for magnesium, for nitrogen, we have 5 valence electrons. So we have how many paired electrons? There's only 1 paired. If we strictly follow arranging the dots, and we have 3 unpaired. Okay, so that is sodium. For main group metals such as sodium, the number of dots is the number of electrons that are lost. For non-metals in the second period, the number of unpaired dots is the number of bonds the atom can form. That will be explained further. Now, therefore, what do we do next? Valence electrons for elements. Recall that the valence electrons for the elements can be determined based on the element's position on the periodic table. So again, take a look at the dots and its group number. So if the element is fluorine and it's found in group 7, there will be 7 dots. Okay? There will be 7 dots. And another thing to remember also is that valence electron will determine also the number of bonds. The number of bonds elements prefers depending on the number of valence electrons. So if we have 1 bond, okay, 1 bond for 1 valence electron, or the electron, it needs 1 electron. So usually single bond sila. So chalcogens, 2 bonds often, nitrogen, 3 bonds often, and carbon, 4 bonds as always. Okay, please take note. Now, so the Lewis structure and the octet rule, when compounds are formed, they tend to follow the octet rule. Okay, octet rule, or what do we call that? Full valence. Atoms will share electrons. Okay, full valence. Atoms will share electrons until it is surrounded by 8 valence electrons. Or the octet rule works mostly for second period elements. Okay, many exceptions, especially in the third period elements. Okay, so therefore, class, when an atom gives up electron or gains electron, what will it form? It will form ion. So the neutral atom, loss of electron turns into cation, and gain electron turns into anion. How do we name these ions? If it is cation, we simply name the neutral atom. We simply name the symbol of the element. Okay, so how to name cations? So if we have sodium positive, therefore you just simply say sodium. Cations, what if we have calcium positive 2, therefore it means it's just say calcium. That's how we name it. But if the elements belong to, if the elements belong to the, you call this, to the transition group or group B, do you see there on the screen? How many charges do we see? There are two charges mostly in an element. So how do we name this? How do we name this? Because it has two charges. This one, we simply name it as lithium, sodium, okay? What about the one with two charges, like iron? Iron has positive 2 and iron has positive 3. So we name it by naming the symbol, the name of the chemical symbol with Roman numeral 2. The 2 represents here the charge, positive 2. 2 electrons are given up here. So we have another iron positive 3. Okay, iron 3. Now, what about if these are anions? How do we name an ion? An ion ends with IVE. So this is nitride. This is phosphide, not phosphoride. This is sulfide, selenide, chloride, bromide, fluoride. So an ion ends with IDE. So again, why ions are formed? Because some neutral atom has tendencies to give up electrons, okay, in order to achieve valence electrons, thus forming into cation. So neutral atom, cation. Neutral atom may change into an ion. Okay. So if we have sodium atom and sodium ion, which one, which one is bigger? Which one is bigger? So, of course, this one, positive sodium ion, positive 1, okay? This one loses electron, right? Therefore, therefore, this one is bigger than the sodium ion, okay? Sodium ion, please take note. So, just to recap, how do you write the Lewis structure? Lewis structure is written using a chemical symbol and the dots. Using a chemical symbol and the dots. So again, this is how you write the Lewis structure. Okay? That ends my discussion.